Hi guys, how you doing? Welcome back to another video. I am excited for this one. It's time to finally get back into some content that I enjoy, which I do like updating you guys, but I must say more than anything, I like learning. So as you know, if you watch my last few videos, I've started my new job now, so I'm no longer a controls engineer. I'm not really like working for a system integrator. So now I'm doing electronics embedded stuff, but I'm still gonna be doing a lot of PLC and hydraulic stuff, but that's probably a bit further down in the pipeline. Right now, I need to get pretty good at microcontrollers. So, since Matrix are an educational company, what they actually do have, if I go onto their website, if I scroll down here to Learning Center, they have a whole bunch of curriculums. So if I just turn off this, they got a whole bunch of curriculums. So the good thing is if I want to learn microcontrollers, I can scroll down until I get to there. Introduction to Microcontroller Programming. I view the course, click that. That pops open this 101 page curriculum where, thankfully, someone like myself can learn microcontrollers. So I have this board here, which is part of Matrix's E-blocks range. So if I go up to the top to products, E-blocks. So I have in front of me, I have this combo board as well as this PIC. No, sorry, not this one. This is the DIP, the dual inline package. Oh, you can't see it, sorry. So I have this PIC microcontroller, but not exactly this one. This is a dual inline package one. So I've got this combo board and then this PIC programmer. So if I take you over to here, that chip there is a PIC 16. Damn, can't remember. It is a PIC 16F18877. All right, so PIC 16F18877. So it's a PIC microcontroller, and so yeah, I need to learn microcontrollers, and the best way for me to do that is going to be to go through this curriculum. So if we quickly go over here, the curriculum, it covers a fair bit. Now I'm not going to go through the introduction to microcontrollers just because that goes into a whole bunch of nice, good to know detail about you know, a CPU, inputs, outputs, clock signals, etc. It goes into the difference between digital and analog signals, how we read analog data into a microcontroller in terms of resolution and splitting it all up into 20 millivolts per step and all that sort of stuff, as you can see there. So if you'd like to learn this, it's important to know. And to be honest with you, I'm about 50-50 with most of this stuff. Like, I understand that microcontrollers have different groups. You've got port A, port B, port C, port D, etc. So yeah, the curriculum in the beginning for like the first 30 pages just goes into a whole bunch. Let's go over here. Goes into a whole bunch of detail about the microcontroller, basically, which in this case is a PIC microcontroller. Then it talks a little bit about what EBlocks is. So EBlocks is Matrix's own hardware, which is this hardware here. So you've got an upstream board and you've got downstream boards and you've got different downstream modules. The reason I want to learn about microcontrollers is my first project here at Matrix is actually to develop something like this. So ignore the torch. I don't even know why that's on actually. So there's an ESP32 board there. But yeah, that torch is bright, man. Yeah, so you got an ESP32, which this is an S3, and then you got a touchscreen, capacitive touchscreen display here. And so what they want me to do, or what my boss has asked me to do, is for my first project, is to take this touchscreen and integrate it onto this combo board. Well, not this combo board, but onto a downstream module board like this, so that you can just plug in the touchscreen, and then you can actually program the microcontroller and actually display out to a touchscreen. And so in that way, so these connectors, they just pop off. So you got a combo board, you could plug that in there if you wanted. You could plug the touchscreen in there and then the combo board there, and there's a variety of different ways that you could do it basically. So yeah, I need to learn about microcontrollers. So yeah, we'll put this to the side for now. This is what I'm working with. I mean, it's pretty cool. Like if you look at it, you've got, you know, nice little decent schematics there of what you're looking at. You got some information there about the different ports. I must say, it's a very well made product. You know, perspex glass. If you can't tell, there's perspex glass on top of that. Yeah, I mean, I'm impressed. The hardware, Matrix's hardware, is excellent. So we'll go through the curriculum and let's see how good the software and curriculum is. So yeah, well, I'm not going to go through any of that. Let's go back up to my thing page, contents page. So we're not going to go over using EBlocks. I've kind of just done that to you. And then introduction to Flowcode. So Flowcode is Matrix's own software. So they have their own IDE, which is basically how you program microcontrollers and how you can develop apps. So you can develop PC apps, you can develop web apps as well. And then what they basically do is you can program all the microcontrollers from here, and they program. So if I pick, I'm using an 8-bit PIC microcontroller. It's a 16F something, but in this case here, the board I'm using is a BL0011. And the unique thing about Flowcode is, kind of as the name suggests, you program in flowcharts. So you can program in C, but I think it's not fully supported. But you can program in C, you can program in pseudocode, and you can program in blocks, in like Scratch and all that. But the main thing here is you can program in flow diagrams and flow codes, which is pretty cool. So you can see here, I can make a switch, decision, etc., etc. So there, it's pretty nice. You know, it looks pretty as well. I like the fact that they got a dark mode, makes me very happy as well. So let's go back. So we're going to start off here in section 4 with first program, and then hopefully in this video or the next few videos, depending on how long it takes me, I think I've got like about 50 pages or so to go through out of 100 pages. So yeah, and it gets into some pretty detailed topics. So there is actually what you'll cover in this module. Let's see if I can find that. So after completing this course, you'll be able to, and then they outline 59 different things. So if we just look at the last 10 or so, use software macros to simplify the structure of a program. Use closed loop control. That's big. Use PWM control to control the brightness of LEDs. Create and use single pin interrupts. Create and use interrupts on change. Use real-time operations of the PIC MCU. Create and use timer interrupts. Use a prescaler to create accurate time intervals, and trigger the timer using the crystal or an external event. So this is all the stuff, you know, like configuring a calculation icon to perform arithmetic and logic calculations. A whole bunch of stuff. Configure and use EEPROM. So yeah, there's a bunch of stuff here to learn. So I'm excited to get through it. So I don't know how long it's going to take me. It depends on how slow I am. Usually I'm recording these videos at midnight, so it doesn't really help my brain, especially if I haven't had a nap. In today's instance, I have had a nap, so I should be pretty on it. So yeah, Flowcode first program. So are we ready? Are we ready, gang? Should we start? Let's stay like this for now. So we want to add digital outputs, light the LED. Create a program that lights an LED attached to the microcontroller. This program introduces the topic of how to control a digital output. Cool. So we create a project, which I've already done. Now we want to add an LED array. So again, this is written, this whole curriculum here is 101 pages, are written for college kids. So a 16-year-old can learn about microcontroller programming. So they can start with this curriculum, read through the top bit, which, let's be honest, no one's going to read through, and then they can start programming this microcontroller. So it should be, you know, me as a 32-year-old experienced engineer, I should have no problem understanding this. So yeah, it's either the curriculum's bad or I've got a problem. So yeah, I'm gonna go with the latter. All right, so the LED array can be found under outputs, components, library, tools. So let's do that. So if we go over here, component libraries, outputs, and then we want an LED array, 2D, drag that onto there. It's giving me port A. I don't know if you can see that really. It's a bit. All right, so then we want to drag LED, blah, blah, blah. Create a flowchart. Move the cursor over the loop icon in the icon toolbar. Click and drag it over the work area. Blah, blah, blah. So we want to drag on a loop and then an output and set that to port A. So if we go for a loop, an output, and it's set to port A, but we want to write. Okay, we're writing a 0. That's fine. Okay, change in port settings. Double click on the output icon and go to properties. Go to properties. There we go. And then we want port B, and we want to write 1 to it. So port B and write 1 to it. So, or true. So what I've done there is, here we've got different ports. So I remove this. Port A, B, C, D, and E. All the different E-blocks, they have a different number of ports depending on how many pins the specific microcontroller. So they've got microcontrollers for ESP32, for AVR, ARM, etc. So that's port A, that's port B. So I'm now setting that while true, I'm turning this output on. So I'm going to skip ahead. No, let's not skip ahead. Let's follow the curriculum to a T. You have done this because the LEDs in your 3D system panel are currently attached to port B. So we're sending the output to the same port. Select the go icon from the debug. So now we're going to run in simulation mode. Cool. Do that. So debug, run. And so now the simulation is either going too fast or too slow. Looks like too fast, so I can speed it up. There we go. So now what's happening? So the program's running. I'm turning port B to true, but you probably can't see it. But here, this is set to A. So let's change that to A. How do I do it? I've got to stop this simulation. This, port A. Boom. That's now true. Run that again. There we go. So we're setting the output for port B to 1. Why is only one LED coming on? Why not all? I'm turning that whole port on. Why would not? But yeah, no, yeah, just that one. Okay. I guess because we're setting it to true, which is basically setting it to 1. If I set it to 255, because 8 bits, then all of them will turn on. That's what. Let's deviate from the course a little bit and just confirm that I'm not crazy. So run that. There we go. See? Know what I'm talking about. So if we set it to 64. Run that. This one. Oh, that one. Yep. Go. Alright. Bob's your uncle. Let's carry on. So. Want to save it and compile to target. Fun. That's fun. Can I turn on all of them? Just to. For the lols. Oh no, go on. Let's just follow it. So set it to 1 and let's build, compile to target. Got to save my project. Is that compiling? That is compiling. So are we now going to see this? You can see that all resetting now. So hopefully we should see this bottom LED turn on. Yay! Nice. And then if I change that to 255, we should get all of them on. Or if I change it to 254, we should get all of them except the last one, except this one, except bit 8. 3, 2, 1. Ah, yeah, I'm dumb. Yep, yeah, of course, because that is like whatever 1, 2, 128. That's 128. So yeah, I'm turning on that one. If you caught that, well done. Yeah, so this is 254. Then add 1 to get 255. Cool. All right, I'm happy with that. Carry on. So I can change my colors of my LED on simulation. I obviously can't change it on the hardware. So if I change that to red, and then I guess I could run simulation now, and then they'll go all red. Yep. So we can change visually how it looks. Can I get rid of the grid? I guess the grid's probably a good thing, but label color. Okay, we can make it black. There we go. And then can I make it any bigger? Okay, we're getting somewhere. Can I make this window bigger? I can make the window bigger. So hopefully you guys can see that a bit better now, but it'd be nice if I can change the text size. I'm deviating from the course again here, but all right. Okay, let's carry on. Properties. No. All right, let's carry on. So where are we at? Changing the port settings. Bring up the output icon properties, double click and change the port setting to port A. What? Okay. Highlight the image of the LED array in the 3D system panel. Right click to select properties and change to port A. So what do you want me to do? The LEDs or the output? Output. So this output to port A. Let's just set that back to 1 again. To port A. But how did it they had a different menu. So where was that? Oh, that was over here. Is it this one? No, here. Port A there. And then set the output to 255 on port B. Is that right? The output, run in simulation mode and then compile to chip. You should see the first LED of the other row light up. Okay. Which you can't see because I've now changed that to port A. But alright, if I just build and compile. The formatting is a bit bad there. Like, I don't really know what I'm looking at here. It's a bit It's just too much at me. I'm seeing text on the right. You know, I would like a figure number here. You know, figure 1, figure 2, figure 3, a caption for each image. Right now, I'm just like, whoa, what is going on? All right, so what did we get on our physical device? The 255 we turned on port B, all of them. So what was it asking us to do? It was asking us to turn on, to set our output to port A. Okay, so how did I mess that up? So set the output to port A, and then we should see the top row of LEDs turn on. So all of these should turn off, and all those turn on up at the top. 3, 2, 1. You're back in the room. There you go. All right, so we're good there. Okay, you can practice changing the ports by changing them back to port B. Change the value from 1 to 255. Okay, so I've already done that. That's good. I never asked you to do that. So binary numbers. We're not going to go into binary numbers because I'm somewhat okay with binary numbers. Oh, look, it's got a little worksheet. That's nice. Shade in the LEDs that light for the first 3 rows. Work out what number precedes the LED. Go on. Let's do 2. So 51 is 128, no. 64, no. Then it's 32, yes. Right? And then 16. So 32 plus 16, 42, 48. So that's a yes. Right? 48, and then we don't want to add 8. That'll go too high. We don't want to add 4 because that'll be 52. So then we want 3. Ooh. So if can I bring up a calculator? Does the calculator have binary? Programmer. There we go. So I want 51, and that in binary is, look at that. Oh wait, hang on, sorry. You got 0 0 1 1 0 0 1 1. Look at that. Your boy can count in binary. So let's do this one here. So this is, what is this? 128, 64, and then this is 36, right? 64, 32. 32, add 16, which is 48, add 8, which is 56, add 4, which is 60. Yeah? So, how do we confirm this now? Do we do, well, 60 is, nah, damn, that's wrong. That's kind of obviously wrong as well, actually. Start again. Bloody hell. All right. Embarrassing myself here. Let's count this way. 1, 2, 4, plus 8, 12, plus 16, 28, plus 32. Wait, what? It's 60. You what, mate? Am I losing it? Ah, I'm going to have to give up. Why can I not count in binary? 60 in binary. What's that? Yeah, look. I'm right. 1 1 1 1 0 0. I'm right. I don't care. Tell me if I'm wrong there, but I think I'm right. All right. Anyways, moving on. All right. What's next? So, example 1, and I think I'll wrap up this video after this one. So, a large building has a number of heat sensors in its fire alarm. Ooh, I like this. So they're given a real world example here, which is cool. So, when there is a fire, the fire brigade needs to know where the fire is. Ah, yeah, okay. So basically, we've got some inputs here, which are going to be our, the inputs are our push buttons. I guess one of these rows. Let's say these push buttons are our inputs, and then they're writing to our outputs, which are our LEDs, probably at the bottom, I guess, or something, maybe even the same. No, although based on the schematic, you can't use that. So yeah, so probably inputs, push buttons, outputs, LEDs. So if there's a fire, you get an input on that one, on one of these push buttons, and then that triggers an alarm LED or something, a buzzer on these outputs here. I guess that's what we're going for. So in other words, you need to know where the heat sensors trigger the alarm. The system is controlled by a PIC device. There are 5 heat sensors connected as an input to port A. Port B is set up as the output port and connected to a set of 5 LEDs. If a heat sensor, I want my LEDs. Ah, damn, sorry guys, I've been bloody programming. I'll get there, I apologize. So, I've just dragged on some switches, and oh my gosh, you guys have probably missed a ton. Alright, quickly redo it, because I've just been talking nonsense, and you guys haven't been able to see it. Damn! Buggers. Alright, anyway, so, I dragged on an input, I dragged on an output, and I didn't have, so my input is my switches up at the top here, and my output is going to be my LEDs. So I want my LEDs to be on port B, and then my input, I need to create a variable. I made one called sensor. Let's just delete it for now. Make a new variable, add new sensor, and set the initial value to 0. It's a byte, blah blah. All right, start again. Bloody hell. Sort yourself out, Hamid. So now I'm writing my inputs from port A to a variable called sensor, and then I now want to write that sensor value, all of that, to port B. So if I download that now, although I don't have my simulation working correctly yet. But so what that should do, that should just take any of these push buttons here, and they should then go onto this LED array here. So there is a bit of a hardware issue here, whereby when you press the push buttons at the top, the LEDs turn on, just because they're linked together. So there's nothing you can do about it. It just turns on by itself. But anyways, that works now. So as I'm pressing each one of these, as I'm getting an input, it's writing it to this bottom output. So that works. That's nice. So if I wanted to fix up the simulation, I would then go to my LEDs, make that 5, I guess. Yep, there you go. And then my switches, how do I get that? Component libraries, inputs, switch array, there. And I guess change that count to 5 again. Make it a bit more big and pretty. And then I guess this needs to be, switches need to be port A. And LEDs need to be port B. And then if we simulate that, we should get the same result. Press that on. Yep. Press that one on. That one. That one. So if there's a fire and you get the sensor input there that there's a fire, then it turns on output there. My screen looks a bit washed out as well. Bloody hell. I'll sort myself out, guys. I promise. I will. All right, cool. So what's next? Simulating the program, blah blah blah. All right, that's done. Cool. All right, I'm gonna stop this one here because I'm starting to make mistakes. So it's bedtime now. I'm gonna go to bed, and then tomorrow we will start with this example 2, which is using loops. The counting sheep badly at first, but without falling asleep. I better not do this one too late. But yeah, so that will be on to the next program. I don't know what page I'm on now. Editing, what page? Let's see, look, there's another, this is more formatting issues. You should always have page numbers at the bottom of your document. So if I go over to I am on page, I've gone too far. No, I haven't. Where am I? Here. I am on page 52. So 52 out of 101. So yeah, hopefully you guys enjoyed this one. I did. I mean, it's nice to get back into learning. I'm really looking forward to using this. I mean, this just looks like a nice bit of kit. And there's some other modules that I can get. There's more push buttons, there's more LEDs, there's some SD cards. So I think I can get pretty fancy with this. And for comparison, you know, I think this is the kind of stuff I've been using before. It looks, I mean, it does the job, don't get me wrong, you know. That does the job, but it doesn't look very professional. Compare that to that. I mean, it's insane. Obviously, I guess this is much cheaper, but yeah. Cool. Anyways, all right. Thanks for watching, guys. I shall see you in the next one. Take care. Hope you enjoyed it. If you did, let me know. And apologize for all my cock-ups. Take care. Bye-bye.